Have you ever seen people asleep around campus? Or maybe in classes like this one? Has a sleeping person ever been you? Well, you're probably falling asleep on campus anywhere and everywhere because you aren't getting enough sleep. And you're probably not getting enough sleep because you don't know enough about it. But don't worry, we're here to educate you.
Y'all, what is sleep?
So, what exactly is sleep? The Harvard Medical School Division of Sleep Medicine defines sleep as a state that is characterized by changes in brainwave activity, breathing, heart rate, body temperature, and other physiological functions. This state is less demanding on our body, and therefore a few of the human body's functions are affected.
So, why do we sleep?
Sleep is a main function of our body that every human being does, so it would seem like it would be easily explainable process, right? Not necessarily. Sleep is something that scientists continue to study regularly. The big question about sleep is why our body does it. According to Ray Metis of the University of Technology, Loughborough, there are three main theories as to why we sleep.
The first theory is that sleep is an instinct that we developed. Metis defines an instinct as an innate biological force which predisposes the organism to act in a certain way. According to this theory, the habit of sleeping became an instinct because it is a vital part of survival. In other words, we developed the practice of sleeping because it is necessary for our body to continue functioning properly.
The second theory is that sleep occurs because the central nervous system switches off in response to fatigue from the day. The theory states that the central nervous system, which includes your brain and your spinal cord, is responsive to an internal body clock, which triggers sleep prep behavior like drowsiness or fatigue at specific times of the day. And this process occurs because the brain needs to reprogram and refresh itself from the next day, as well as to process emotions from the previous day.
The third theory is known as the sleep control mechanism. This theory is that the desire for sleep is triggered by the internal body clock, or the time of day that the brain thinks it is necessary for the body to sleep. At this time, the body makes sleeping the highest priority. The motive for the body to sleep is not because the body needs rest, but simply because the body is on a regular schedule.
While you're fast asleep, your brain moves through 5 different stages. These are aptly named 1, 2, 3, 4, and REM. These stages rotate in a cycle, averaging 90 minutes for the whole cycle. Obviously, at night we sleep for more than an hour and a half, so this cycle repeats itself. With each sleep cycle that occurs, typically 4 to 5 each night, the amount of deep sleep decreases and the time spent in REM increases. Now let's talk about what those random numbers actually mean. Stages 1 and 2 of the sleep cycle are considered light sleep. You know when you're just starting to fall asleep and all of a sudden you jolt awake? Well, that's not you coming close to death. You've got stage 1 of sleep to thank for that. In stage 1, you're easily woken up and may not even believe you were asleep. Your typical beta waves in your brain, the natural brain waves in an awake state, begin to slow down. Stage 2 is deeper than that, but not by much. The creepy closed eye movement stops and your body temperature and heart rate drops. Your now relaxed alpha waves slip into the unconscious theta waves. Stages 3 and 4, or 3 and N3, make up what we call deep sleep. This is that point where you're super confused about the year you're in when you're woken up. These are the stages that people experience night terrors, bedwetting, and sleep talking and walking. This deep sleep is constituted by delta waves, brain waves that are much longer and slower than typical brain speed. Stages 1, 2, 3, and 4 make up what is called non-REM sleep. The other major part of sleep, REM, stands for rapid eye movement. REM takes up the most time throughout a night of multiple cycles. Your breathing becomes irregular, your eyes move rapidly, and your body is temporarily paralyzed. Your heart rate and blood pressure skyrockets. Kinda freaky to hear about, huh? Good news, you shouldn't ever remember it. During REM, your brain reverts back into your typical woken alpha rhythm, which explains the irregular breathing and all of the other stuff. Due to the sleep cycle, it's important to get a full night's sleep. If you don't go through enough sleep cycles, your body doesn't balance out the right amount of deep sleep and REM. Deep sleep is what's necessary to keep you running at full steam the next day.
So what are the effects of sleep deprivation?
Studies have shown that sleep deprivation can result in a decrease of glucose and oxygen levels in our brain, which affects the functioning of 3 brain regions: the thalamus, prefrontal cortex, and posterior cortex. These regions are associated with attention, focus, and complex mental tasks like verbal fluency, logical reasoning, decision-making, and creative thinking. With these processes impaired, we're more likely to do poorly on exams and homework assignments, resulting in worse scores and lower GPAs. In fact, in a study done by Dr. Mickey Trockle, it was shown that out of 200 college freshmen, poor sleep schedules, including sleeping late, showed a .13 grade drop for every extra hour the student slept in. Sleep is essential to memory, so when we don't sleep enough, our brains can't review and store away memories for later recall, a process called memory consolidation. Consolidation of different types of memories have been shown to correspond with different stages of sleep. For example, procedural or muscle memory is associated with stage 2 sleep, while logic-based memory is affected by REM sleep. Not only are our memories affected by the amount of sleep we get, but when we get too little sleep, our synapses can't prepare for what we're going to learn the next day. While we're sleeping, the synaptic connections in our brain are being pruned and shortened, which is a good thing. Though the most important synapses are left untouched, the ones storing the non-essential information we've learned throughout the day are trimmed, getting rid of excess, unimportant information so that our brains are ready to learn new things the next day.
Now that you've learned the importance of sleep, the stages, and the effects of sleep deprivation on your cognitive abilities, sit back, relax, and get some sleep, y'all.